Hello everyone, welcome to today's session. In the last session, we covered the random forest. So today's topic is KNN algorithm. And what is the KNN algorithm? Well, K nearest neighbor is the simplest algorithm that stores all the variable cases and classifies the new data or case based on a similarity measure. It suggests that if you are similar to your neighbor, then you are one of them. For example, if an apple looks more similar to a banana, orange, or melon rather than monkey, cat, or rat, then most likely apple belongs to the group of fruits. Well, in general, KNN is used in search applications where you are looking for similar items. That is, when your task is some form of fine items similar to this one, then you call this search a KNN search. But what is the K in KNN? Well, this K denotes the number of nearest neighbors which are voting class of the new data or the testing data. For example, if K equals 1, then the testing data are given the same label as a close example in the training set. Similarly, if K is equal to 3, the labels of the three closest classes are checked and the most common label is assigned to then testing data. So this is what a K in KNN algorithm means. So moving on ahead, let's see some of the examples of scenario where KNN is used in the industry. So let's see the industrial application of the KNN algorithm. Starting with the recommender system. Well, the biggest use case of KNN search is the recommender system. This recommender system is like an automated form of a shop counter guy. Well, you ask him for a product, not only shows you a product but also suggests you or displays you relevant set of products which are related to the item you are already interested in buying. This KNN algorithm applies to recommending products like Amazon or for recommending media like in the case of Netflix or even for recommending advertisement to display to a user. If I'm not wrong, almost all of you must have used Amazon for shopping. So just to tell you more, then 35% of Amazon.com revenue is generated by this recommendation engine. So what's their strategy? Amazon uses recommendation as a targeted marketing tool in both the email campaign around most of its website pages. Amazon will recommend many products from different categories based on what you have browsed, and it will pull those products in front of you which you are likely to buy, like the frequently bought together option that comes at the bottom of the product page to tempt you into buying the combo. Well, this recommendation has just one main goal, that is to increase average order value or to upsell and cross-sell customer by providing product suggestions based on item in the shopping cart or based on the product they are currently looking at on site. So the next industrial application of KNN algorithm is concept search or searching semantically similar documents and classifying documents containing similar topics. So as you know, the data on the internet is increasing exponentially every single second. There are billions and billions of documents on the internet. Each document on the internet contains multiple concepts. That could be a potential concept. Now, this is a situation where the main problem is to extract concept from a set of document, as each page could have thousands of combination that could be potential concept. An average document could have millions of concepts combined with a vast amount of data on the web. Well, we are talking about an enormous amount of data set and samples. So what we need is to find the concept from the enormous amount of data set and samples. So for this purpose, we'll be using KNN algorithms. More advanced examples could include handwriting detection like an OCR or image recognition or even video recognition. So now that you know various use cases of KNN algorithm, let's proceed and see how it works. So how does a KNN algorithm work? Let's start by plotting these blue and orange points on our graph. So these blue points belong to class A and the orange ones belong to class B. Now you get a star as a new point and your task is to predict whether this new point belongs to class A or it belongs to class B. So to start the production, the very first thing that you have to do is select the value of k. Just as I told you, the k in KNN algorithm refers to the number of nearest neighbor that you want to select. For example, in this case, k is equal to 3. So what does it mean? It means that I am selecting 3 points which are the least distance to the new points, or you can say I am selecting 3 different points which are closest to the star. Well, at this point of time, you can ask how will you calculate the least distance? So once you calculate the distance, you will get one blue and two orange points which are closest to this star. Now, since in this case we have a majority of orange points, so you can see that for k equal 3, the star belongs to the class B, or you can say that the star is more similar to the orange points. Moving on ahead, well, what if k is equal to 6? Well, for this case, you have to look for 6 different points which are closest to this star. So in this case, after calculating the distance, we find that we have 4 blue points and 2 orange points which are closest to the star. Now as you can see that the blue points are in majority, so you can say that for k equals 6, this star belongs to class A, or the star is more similar to blue points. So by now, I guess you know how a KNN algorithm works and what is the significance of the k in KNN algorithm. So next is how will you choose the value of k? So keeping in mind this case, the most important parameter in KNN algorithm. So let's see, when you build a k nearest neighbor classifier, how will you choose the value of k? Well, you might have a specific value of k in mind, or you could divide up your data and use something like a cross validation technique to test several values of k in order to determine which works best for your data. Example, if n equal 1000 cases, then in that case, the optimal value of k lies somewhere in between 1 to 19. But yes, unless you try it, you cannot be sure of it. So, you know how the algorithm is working on a higher level. Let's move on and see how things are predicted using the KNN algorithm. Remember, I told you the KNN algorithm uses the least distance measure in order to find its nearest neighbors. So let's see how these distances are calculated. Well, there are several distance measure which can be used. So to start with, we'll mainly focus on Euclidean distance in Manhattan distance in this session. So what is the Euclidean distance? Well, this Euclidean distance is defined as a square root of the sum of difference between a new point x and an existing point y. So for example, here we have point P1 and P2. Point P1 is 1, 1 and point P2 is 5, 4. So what is Euclidean distance between both of them? So you can say that Euclidean distance is the direct distance between 2 points. So what is the distance between the point P1 and P2? So we calculate it as 5 minus 1 whole square plus 4 minus 1 whole square, and we can root it over which result to 5. So next is Manhattan distance. Well, this Manhattan distance is used to calculate the distance between real vectors using the sum of their absolute difference. In this case, the Manhattan distance between the point P1 and P2 is mod of 5 minus 1 plus mod value of 4 minus 1, which results in 3 plus 4, that is 7. So this slide shows the difference between Euclidean and Manhattan distance from point A to point B. So the Euclidean distance is nothing but the direct or the least possible distance between A and B, whereas the Manhattan distance is a distance between A and B measured along the axis at right angles. Let's take an example and see how things are predicted using KNN algorithm or how the KNN algorithm is working. Suppose we have a data set which consists of the height, weight and t-shirt size of some customers. Now when a new customer comes, we only have his height and weight as a information. Now our task is to predict what is the t-shirt size of that particular customer. So this will be using the KNN algorithm. So the very first thing, what we need to do, we need to calculate the Euclidean distance. So now that you have a new data of height 161 centimeter and weight as 61 kg. So the very first thing that we'll do is we'll calculate the Euclidean distance, which is nothing but the square root of 161 minus 158 whole square plus 61 minus 58 whole square, and square root is 4.24. So these are the various Euclidean distance of other points. Now let's suppose k is equal to 5, then the algorithm, what it does is it searches for the 5 customers closest to the new customer that is most similar to the new data in terms of its attribute. For k equal 5, let's find the top 5 minimum Euclidean distances. So these are the distances which we are going to use. So let's rank them in order. So there's our order. So for k equal 5, we have 4 t-shirts which come under size M and 1 t-shirt which comes under size L. So obviously the best case for the best prediction for the t-shirt size of height 161 centimeters and weight 61 kg is M, or you can say that the new customer fits into size M. Well, this was all about the theoretical session. But before we drill down to the coding part, let me just tell you why people call KNN a lazy learner. Well, KNN for classification is a very simple algorithm, but that's not why they are called lazy. KNN is a lazy learner because it doesn't have a discriminative function from the training data. But what it does is it memorizes the training data. There is no learning phase of the model, and all of the work happens at this time your prediction is requested. So as such, there is a reason why KNN is often referred to as a lazy learning algorithm. So this was all about the theoretical session now. Let's move on to the coding part. So for the practical implementation of the hands-on part, I'll be using the iris dataset. So this dataset consists of 150 observations. We have 4 features and 1 class label. The 4 features include the sepal length, sepal width, petal length and the petal width. Whereas the class label decides which flower belongs to which category. So this was the description of the dataset which we are using. Now let's move on and see what are the step-by-step solutions to perform a KNN algorithm. So first, we'll start by handling the data. What we have to do? We have to open the dataset from the CSV format and split the dataset into the train and test part. Next, we'll take the similarity where we have to calculate the distance between two data instances. Once we calculate the distance, next we'll look for neighbor and select k neighbors which are having the least distance from the new point. Now once we get our neighbor, then we'll generate a response from a set of data instances. So this will decide whether the new point belongs to class A or class B. Finally, we will create the accuracy function, and in the end, we'll tie it all together in the main function. So let's start with our code for implementing the KNN algorithm using Python. I'll be using Jupyter Notebook Python 3.0 now. Let's move on and see how KNN algorithm can be implemented using Python. So there's my Jupyter Notebook, which is a web-based interactive computing notebook environment with Python 3.0 installed on it. So the launch, it's launching. So there's our Jupyter Notebook and we'll be writing our Python codes on it. So the first thing that we need to do is load our file. Our data is in CSV format without a header line or any code. We can open the file using the open function and read the data line using the reader function. In the CSV module, so let's write a code to load our data file. Let's execute the run button. So once you execute the run button, you can see the entire training data set as the output. Next, we need to split the data into the training data set that KNN can use to make predictions and a test data set that we can use to evaluate the accuracy of the model. So we first need to convert the flow of measure that will load it as string into numbers that we can work with. Next, we need to split the data set randomly to train and test. So let's define a function as a load dataset that loads a CSV with the provided file name and split it randomly into training and test dataset using the provided split ratio. So this is our function load dataset, which is using file name split ratio training dataset and testing dataset as its input. So let's execute the run button and check for any error. So it's executed without any errors. Let's test this function. So there's our training set, testing set, load data set. So this is our function load data set. Inside that we are passing our file is data with a split ratio of 0.66 and training data set and test data set. Let's see our training data set and test data set. It's dividing into. So it's giving a count of training dataset and testing dataset. The total number of training dataset is split into 97 and the total number of test dataset we have is 53. So the function load dataset is performing well. So let's move on to step 2, which is similarly. So in order to make predictions, we need to calculate the similarity between any two given data instances. This is needed so that we can locate the k more similar data instances in the training dataset and in turn make a prediction given that all 4 flower measurements are numeric and have the same unit. We can directly use the Euclidean distance measure. This is nothing but the square root of the sum of square differences between two arrays of the number. Additionally, we want to control which field to include in the distance calculation. So specifically, we only want to include the first 4 attributes. So our approach will be to limit the Euclidean distance to a fixed length. So let's define our Euclidean function. So this is a Euclidean distance function which takes one instance 2 and length as parameters. Instance 1, instance 2 are the 2 points of which you want to calculate the Euclidean distance, whereas this length and denote that how many attributes you want to include. So there's our Euclidean function. Let's execute it. It's executing fine without any error. Let's test the function. Suppose the data 1 or the first instance consists of the data point has 2, 2, 2 and it belongs to class A, and data 2 consists of 4, 4, 4 and it belongs to class B. So when we calculate the Euclidean distance of data 1 to data 2, and what we have to do, we have to consider only the first 3 features of them. So let's print the distance. As you can see here, the distance comes out to be 3.464. Now, so this is nothing but the square root of 4 minus 2 whole square. So this distance is nothing but the Euclidean distance, and it is calculated as square root of 4 minus 2 whole square plus 4 minus 2 whole square. That is nothing but 3 times of 4 minus 2 whole square, that is 12, and square root of 12 is nothing but 3.464. So now that we have calculated the distance, we need to look for k nearest neighbors. Now that we have a similarly measure, we can use it to collect the k more similar instances for a given unseen instance. Well, this is a straightforward process of calculating the distance for all the instances and selecting a subset with the smallest distance value. And now what we have to do is select the smallest distance value. So for that, we'll be defining a function as getNeighbors. What it will do? It will return the k more similar neighbors from the training set for a given test instance. So this is how our neighbors in look like. It takes training data set and test instance and k as its input. Here the k is nothing but the number of nearest neighbors you want to check for. So basically what you will be getting from this getNeighbor function is k different points having least Euclidean distance from the test instance. Let's execute it. So the function executed. So let's test our function. So suppose the training data set includes the data like 2, 2, 2 and it belongs to class A, and other data includes 4, 4, 4 and it belongs to class B, and at testing instances 5, 5, 5, or now we have to predict whether this test instance belongs to class A or it belongs to class B. For k equal 1, we have to predict its nearest neighbor and predict whether in this test instance it will belong to class A or will it belong to class B. So let's execute the run button. So by executing the run button, you can see that we have output as 444 and B, a new instance 555, is closest to point 444, which belongs to class B. Now once you have located the most similar neighbor for a test instance, the next task is to predict a response based on those neighbors. So how can we do that? Well, we can do this by allowing each neighbor to vote for the class attribute and take the majority vote as a prediction. Let's see how we can do that. So we function as getResponse, which takes neighbors as the input. Well, this neighbor was nothing but the output of this getNeighbor function. The output of getNeighbor function will be fed to getResponse. Let's execute the run button. It's executed. Let's move ahead and test our function to get a response. So we have a neighbor as 111. It belongs to class A. 222. It belongs to class A. 333. It belongs to class B. So this responded. What it will do? It will store the value of get response by passing this neighbor value. So what we want to check is, we want to predict whether that test instance 555 belong to class A or class B. When the neighbors are 111A, 222A or 333B. So let's check our response. Now that we have created all the different functions which are required for KNN algorithm. So the main concern is, how do you evaluate the accuracy of the prediction? An easy way to evaluate the accuracy of the model is to calculate a ratio of the total correct prediction to all the protection made. So for this, I will be defining a function to get accuracy, and inside that I'll be passing my test data set and the predictions. Get an accuracy function, check it. So it's executed without any error. Let's check it for a sample data set. So we have our test data set as 111. It belongs to class A. 222, which again belongs to class A. 333, which belongs to class B. And my prediction is, for the first test data, I predicted that it belongs to class A, which is 2. For next, it predicted that it belongs to class A, which is again 2. And for the next, again, and predictive, that is belong to class A, which is false in this case, cause the test data belongs to class B. So in total, we have 2 correct predictions out of 3. So the ratio will be 2/3, which is nothing but 66.66. So our accuracy rate is 66.66. So now that you have created all the functions that are required for the KNN algorithm, let's compile them into one single main function. So this is our main function, and we are using the Irish dataset with a split of 0.67 and the value of k is 3. Let's see what is the accuracy score of this. Check how accurate the model is. So in the training dataset, we have 97 values, and then the test dataset, we have 53 values. These are the predicted and the actual values of the output. So I hope the concept of this KNN algorithm is clear. So this is all about the KNN algorithm. If you require a source code file, I have already mentioned the link in the description. And if you have any doubt, you can drop your doubt in the comment section. Thank you so much guys for watching our video.